This video will cover section 4.3 homework, domain and range. Let's get started. Question 1 says select all of the following tables which represent y as a function of x and are one-to-one. Remember that if y is a function of x, that means that for every x value, you have only one y value. If a function is one-to-one, then the reverse is also true. In practice, this means that x does not repeat and y does not repeat. I can create a table to help me remember these basic rules. If x repeats, then it is neither a function nor is it one-to-one. If x does not repeat, but y does repeat, then it is a function, but it is not one-to-one. It is only if x does not repeat and y does not repeat that it is both a function and one-to-one. If I look at the first answer choice, I can see that I have 3 different x values. This means that the first table is a function. However, the y value of 8 repeats twice. This means that the first table is not one-to-one. The second table has repeating x value of 9. This means that the second table is not a function and cannot be one-to-one. The third table does not have any repeating x values, making it a function. It also does not have any repeating y values, meaning it is also one-to-one. So only the third table with no repeating x or y values is both a function and one-to-one. Question 2 is the same as question 1. I need to select all of the following tables which represent one-to-one function. Just like on question 1, a function means that for every x value, you have only one y value, or x does not repeat. If a function is one-to-one, then each y value is only paired with one x value. Y does not repeat. Looking at the first table, none of my x values repeat, meaning this table is a function. None of the y values repeat either, meaning it is also one-to-one. On the second table, x does not repeat, so it is a function. However, the y value of -1 does repeat, meaning it is not one-to-one. On the third table, x does not repeat, so it is a function. But the y value of 1 does repeat, meaning it is not one-to-one. On the fourth table, x does not repeat, so it is a function. Y does not repeat either, so it is also one-to-one. Question 3, similar to questions 1 and 2 before it, wants us to select all of the following graphs which represent y as a function of x and are one-to-one. Since we don't have a table of ordered pairs to look at, I will use the vertical line test and the horizontal line test. You should already be familiar with the vertical line test for functions. If there is any point on the graph where a vertical line can touch the equation more than once, it is not a function. The horizontal line test can be used on graphs of functions to determine if they are also one-to-one. If there's any point on the graph where a horizontal line can touch a function more than once, it is not one-to-one. In order to use the horizontal line test, the equation must first pass the vertical line test. Only functions can be one-to-one. The first graph is not a function because I can put a vertical line through it right here and have it touch more than once. The second graph is not a function either because I can have a vertical line here and touch it twice. The third graph passes the vertical and horizontal line tests, so it is a one-to-one function. The fourth graph passes the vertical line test and is a function, but it fails the horizontal line test and is not one-to-one. The fifth graph passes both the vertical and horizontal line tests, so it is a one-to-one function. And the sixth graph passes the vertical line test and is a function, but fails the horizontal line test and is not one-to-one. Question 4 is the same as question 3. Select all of the following graphs which are one-to-one functions. Remember that we can use the vertical line test to look for functions, and the horizontal line test to check if functions are also one-to-one. If a vertical line touches the equation more than once, it is not a function. If a horizontal line touches a function more than once, it is not one-to-one. Only functions can be one-to-one. This graph passes the vertical line test and is a function. It also passes the horizontal line test and is also one-to-one. This second graph also passes both tests and is also a one-to-one function. The third graph fails the vertical line test and is not a function. The fourth graph passes both and is a one-to-one function. The fifth graph passes the vertical line test and is a function, but fails the horizontal line test and is not one-to-one. The sixth graph passes both tests and is a one-to-one function. Question 5 wants me to find the domain of the function f of x equals x plus 8 divided by negative 9 minus x. Remember that domain is your input and most often associated with the x value of a function or equation. There are two primary operations that can limit the domain of a function. You can't divide by 0, and you can't take the square root or other even root of a negative number. This means that if there is a variable that is dividing something, or a variable inside of a square root symbol, then there will be a certain number or numbers that cannot be part of the domain. If there are no variables dividing or inside of a square root, then the domain will be all real numbers. Looking at this function, I can see that I have an x in the denominator. This means there will be a limit on the domain. In order to figure out what number will cause this function to divide by 0, I need to set the expression in the denominator equal to 0 and then solve for x. I'll set this up on my scratch paper as negative 9 minus x equals 0. I need to get the negative 9 to the other side of the equal sign, so I'll add 9 to both sides to move it over. The 9's on the left side will cancel, giving me negative x equals 9. Remember that if there is not a number in front of x, then I can assume there's a 1. This allows me to divide both sides by negative 1 to get positive x by itself on the left side of the equation. The negative 1's on the left side will cancel, and 9 divided by negative 1 is negative 9, giving me x equals negative 9. If I test that number by plugging it in parentheses, I'll have negative 9 minus negative 9 equals 0. Negative times a negative will give me a positive, and I'll have negative 9 plus 9 equals 0. Negative 9 plus 9 is 0, so this answer checks out. This means that for my domain, x cannot equal negative 9. However, the question wants me to enter the domain in interval form. Since x cannot equal negative 9, I know that the domain includes all the numbers from negative infinity up to but not equal to negative 9. It also includes all the numbers from negative 9 up to positive infinity. I can connect these using a U as the math OR symbol, because a value only needs to belong to one of these sets to be part of the domain for this problem. So my final answer is parentheses negative infinity, comma, negative 9, close parentheses, U, parentheses, -9, comma, infinity, close parentheses. Similar to question 5, question 6 wants me to find the domain of the function f of x equals x squared plus 21. Remember that the only things that can limit the domain are dividing with a variable or taking the square root or even root of a variable. Since neither of those are happening in this function, there are no limits on the domain. This means the domain is all real numbers from negative infinity to positive infinity. I can enter this answer as parentheses negative infinity, comma, infinity, close parentheses. Similar to questions 5 and 6, question 7 wants me to find the domain of the function f of x equals the square root of 9x minus 4. Remember that the only things that can limit the domain are dividing with a variable or taking a square root or even root of a variable. Here, I have a variable inside of a square root. Remember that we cannot take the square root of a negative number. The smallest number I can take the square root of is 0. This means I need to set whatever expression is inside of the square root equal to 0 and solve for x. I will then know the smallest x value in the domain of this function. I'll set it up as 9x minus 4 equals 0. The first thing I need to do is move the negative 4. So I'll add 4 to both sides of the equation. The 4's on the left will cancel out, giving me 9x equals 4. Now I need to divide both sides by 9. The 9's on the left will cancel, giving me x equals 4 divided by 9. 4 divided by 9 does not simplify. Since 4/9 is the smallest value in my domain, I know that x is greater than or equal to 4/9. My question wants the answer in interval form, so I can write that as bracket 4 divided by 9, comma, infinity, close parentheses. Notice that I used a bracket next to 4/9 because in this function, x can equal 4/9. Question 8 wants us to find the domain and range of f of x equals negative 2x squared plus 12x minus 20 from its graph. Remember that domain is your horizontal x values, and range is your vertical y values. In questions 5, 6, and 7, I covered the fact that the only things that can limit the domain are dividing with a variable or taking the square root or even root of a variable. Since neither of those are happening in this function, the domain will be all real numbers. I can also see that by looking at the graph. Unless a line ends in a dot, it will continue going in the same direction or pattern even once it's left the edge of the graph. This means the parabola here will keep getting wider and wider forever. So there is no x value that it will not eventually contain. The question wants the answer in interval notation, so I can enter my domain as parentheses negative infinity, comma, infinity, close parentheses. I also need to find the range. The easiest way to find the range is to look at the graph. Remember that range is the vertical y values. I know the function will continue going down forever, but it stops going up at this point right here where y equals negative 2. This means that negative 2 is the highest y value for your function. If your function has a parabola facing up, this will be a minimum y value. Since mine is a maximum y value, I can write my range in interval notation as parentheses negative infinity, comma, negative 2, bracket. If your y value was a minimum, you'll enter yours as bracket your y value, comma, infinity, close parentheses. Question 9 is similar to question 8. It wants us to find the domain and range of the function f of x equals -1 plus the square root of x plus 6. And it's graphed the function for us. Remember that domain is your horizontal x values and range is your vertical y values. Also remember that the only things that can limit the domain are dividing with a variable or taking a square root or even root of a variable. This function has a variable inside of a square root. Remember that we cannot take the square root of a negative number. If you look at the graph, you can see how the line just stops when x equals -6. This is because if I plug in -6 for x, I'll be taking the square root of 0. Anything smaller than -6 would cause the function to take the square root of a negative number. I can also see that the right-hand side of the equation will keep extending off the edge of the graph, going up and to the right forever. This means I can enter my domain in interval notation as bracket -6, comma, infinity, close parentheses. For my range, I can see that when the line stops on the left, y equals -1. Since I know the right-hand side will continue extending upwards forever, I can enter my range in interval notation as bracket -1, comma, infinity, close parentheses. Question 10 wants me to find the domain of the function f of x equals x divided by x minus 2. Remember that domain is your horizontal x values. Also remember that the only things that can limit the domain are dividing with a variable or taking a square root or even root of a variable. This function has a variable in the denominator, meaning it is dividing with a variable. This means that the graph will approach but never equal the point where x would cause the function to divide by 0. I can see that the graph splits when x equals 2. This is because the variable in the denominator has created what's called an asymptote at x equals 2. An asymptote is a line that the graph will approach but never reach. This means that the domain is all real numbers except 2. This concludes section 4.3 homework, domain and range. If you have any questions, please leave a comment below or contact me through Lumen or Remind. As always, remember to be safe, be smart, and try to make wise choices.